A very good afternoon and welcome to the day 6 of our FDP. We will be having 3 sessions today. May I request all the participants to please inform their colleagues to join in and so that we can actually begin the session fast. I hope you all remember that there will be we will be taking on the ATAL portal from 6:30 onwards. Very, very good afternoon, sirs and ma'ams. Yes, Senthil sir. So, actually, regarding the examination will be conducted on the ATAL portal itself, sir. And the time is as per the schedule, which is like 6:30 to 7:30. You can take the class, you can take the uh, quiz online from the ATAL portal, sir. Senthil sir, do you think any more clarity is needed? Dr. V. Shravan Kumar, regarding OTP. Ganesh sir, it is 6:30. There will be around 30 questions. They are MCQs, and I'm sure that we'll be able to do. Simultaneously, as per the schedule, I think by 8 we'll be able to close the valedictory. Thank you so much, sir. Regarding how to take the exam on the ATAL portal, sir, the moment you go on the ATAL portal, you will see that there is something called as quiz. Okay, so the quiz will be active during the same time. If you want to just try sharing the screen, you may please log into your system. I'll ask the coordinator to give you access, and we can see live where exactly we have this exam. I think by the time we are waiting for other participants, this will be helping everyone so that they can take up the exam in time and it will be seamless. Thank you, sir. Yes, sir, we are using the same link. We haven't changed the link throughout the FTP. Ganesh sir, can I request you to actually log into your portal and see if you're able to see exam so that we can just share the what do you call the screen. It will help other participants also. So where to find and all. Could you please help, Ganesh sir?
What, sir? Please repeat.
Sir, I want you to please log in into your ATAL portal, okay,
Okay.
and go to our
Then.
FTP. Then go to our FTP, sir, okay, and see if you
Okay.
are able to
Okay.
see take test or quiz. If you are able to see that,
Okay. So
if you
right
could,
now I have to do this, or at the
हाँ
time
हाँ,
of
आप
exam.
आप नहीं नहीं, आप अभी कीजिए ताकि हम बता देते हैं लोगों को, okay. So if there is any question that people are facing, it will be resolved right away because we are any which way is waiting for more participants to join, na?
Okay. Okay. I'm trying.
Yes, sir. Thank you. Ganesh sir, do you want me to share the rights to you?
Sir, once I first let me reach on the point, then I will show you.
Yes, yes. No problem, sir. No problem. Any other faculty also who wishes to try, please.
Sir, I have reached on applied FDP after opening my portal.
Yes, sir. From the applied FDP, okay.
Yes.
If you click on the FDP, emerging trends and practical approach to cybersecurity. Yes. Thank you, Santil sir.
But actually, there is I'm unable to go into this option
नहीं, आपको
after.
क्विज दिख रहा है ना उसमें, उसमें you are able to find quiz ना? I think
Uh,
Senthil sir, you have got it right, Senthil sir. Could you please share? Left panel assessment is there. Yes. Thank you
Yes,
so
sir.
much for the direction, sir. Yes, sir.
Sir, actually, we have to click assessment panel. Once we are
Yes.
clicking, it's showing that FDP link. If you are
okay, okay.
clicking it, it's posting there.
Assessment panel. Yes, I have clicked on assessment panel. Then the test link is there.
Yes, sir.
A
And
test
this,
link is
yes.
there. What we have to do now?
No, so that test link will be activated at 6:30. It will go
At the time
active
of
live.
okay.
Yes, at the time of the exam. Yes, that is what we wanted to show.
So
So we
yeah,
just
yeah.
want you to do a practical
I'm
demo.
just showing. I'm just showing, sir.
Ji.
I'm sharing. Sharing is not turned on, sir. Please kindly.
Yes, yes. 1 minute, 1 minute. Yashwant,
Yes, sir, I
if
load.
you, yes, thank you.
Can I share now?
Yes, yes, please, करिए.
Here is there?
अभी तक नहीं आया, sir. It's blank.
Okay.
Sir, click on that share button.
Click on share.
Yes, share. This one. Now, are you able to see?
Yes, sir.
Yes sir. Yes sir.
So here is the one thing.
हाँ अभी असेसमेंट सर अटेंडेंस के नीचे असेसमेंट है देखिए.
Is the test link. Yeah, in assessment,
Yes.
I went through the assessment, and I have this particular page. Application number is there, date from and
Yes.
date to, and test link
Yes.
is there. So
Exactly. उसको क्लिक करेंगे.
according to you,
हाँ.
at 6:30, we have to click in this at this
Yes.
particular link.
Perfect. That's it.
So the test will be running on, no?
Yes sir. Yes sir.
Okay. Okay.
Thank you so much to both Senthil sir and to Gnanesh sir. Sir, you may stop sharing your screen.
Okay, sir. I just stopping. Is it been stopped, sir?
Sorry sir, I didn't hear.
It went stop?
Yeah, you can stop. Yes. Not
Okay,
able
thank
to
you.
see the link test. Ma'am, what is the challenge that you're facing? Yes, the assessment start time is 6:30 p.m. Correct, sir. शर्मिला मैम, आपको क्या प्रॉब्लम हो रही है? क्या दिक्कत आ रही है आपको? Can you please unmute yourself and tell Shamila ma'am?
Hello.
जी मैम.
I'm not able to see the test link.
Ma'am, there, as you saw in the screen share, there is a link that is there. You will have to go to the assessment. Okay,
Yes,
there with the
yeah.
FDP number and all, there will be a small link. वो chain का symbol है मैम. उसको click करना है and it will be live only at 6:30. Okay.
Okay, once again I will check.
Have you logged into your ATAL portal for the participant
Yes.
login?
Yes.
Yes, you have logged in. Okay, you have been to your FDPs?
Yes.
Approved FDPs?
Yes.
Yes. In that, are you able to see this FDP emerging trends practical approach to cybersecurity?
Yeah, I can see, but I can't open it.
हाँ. So once you see that, ma'am, in that you look at the left panel. In that there are options. In that there's an option called as assessment.
Yeah.
Click on assessment.
Okay, but it is showing old one. I will refresh and I will check once again. If any issue, I will call.
So just check through which account you have applied and through which account you are looking at. So probably
Yes.
there would be
Sir, in
that
bottom,
also could
number
be a
of
problem.
FDP, maybe 5 is there. Ask her to select 10. Right side, number of FDP, maybe previous FDP it will show. So number should change. 5
Yes,
to
sir. Yes, sir. Yes, Shamla ma'am, sir is also telling that you might have applied or attended a lot of FDPs. So maybe
Yeah.
that could also be one of the reasons, है ना?
Yeah, that is
Thank you,
old one
Senthil
it
sir.
is showing. I will check
हाँ
it.
हाँ, तो वहां पर जो नंबर है ना मैडम, जो दिखा सकता है वो 5, 10 अपन बढ़ा सकते हैं ना, वहां पे वो ऑप्शन ट्राई कीजिए ड्रॉप डाउन में.
Okay, I will check it.
जी शर्मिला मैम, थैंक यू.
Yeah, thank you.
Thank you, Senthil sir. Any other participants? Are you facing any challenge? So we're just stopping the resource person actually, so that we don't face any challenge during the assessment time, because it's like limited time. You all will be in a lot of thoughts then. So it's better that we sort it now before we get started with the session. Any more colleagues of yours who have joined until day but have not joined the meeting till now? Please, may you request them to join?
Can you hear me?
Very good afternoon, sir. Welcome to the session. You're audible, sir.
Yeah, thank you.
You're welcome, sir. Opera ma'am, may you please begin the proceedings?
Yes, sir.
Thank you. Please go ahead.
Good afternoon, respected faculty, dear participants, and distinguished guests. It's my privilege to introduce our speaker for session, Dr. S. K. Subudali, Associate Professor, Department of Computer Science Engineering, IIT Bhilai. Dr. Ali holds a PhD in Computer Science and Engineering from IIT Kharagpur, and over the years, he has developed deep expertise in critical areas of computing and security. As the head of the MIST lab at IIT Bhilai, his research covers cutting-edge domains such as adversarial machine learning, deepfake detection, hardware security and trust, cybersecurity, and IoT and smart infrastructure security. He has widely contributed to knowledge through publications in prestigious journals and conferences, and holds patents in areas such as secure design and signal verification, reflecting both theoretical and practical accomplishments. Given his strong background in security, data integrity, machine learning, and system architecture, Dr. Ali insights will be especially valuable for our session on cloud security, information management, and data security and cloud security models. Welcome, sir. The floor is yours.
Thank you so much. It was indeed a very good introduction. Um, yeah, it's my privilege to present my research article here. And thanks for inviting me for this session. Yeah. Okay, very good afternoon to all the attendees and dignitaries and respected faculty members. As you were told, my name is Dr. Subir Ali. I precisely worked on security, and I was told to talk about cloud security for this session. And for this session, what you would see, I will be talking about a lot on AI. So basically, whenever you have any doubts or any question, you should knock me out, and I'll uh, try to explain as much as possible. And I think I originally had around 1.5 hours. So now, like, yeah, if you allow me, I'll continue, but I'll try to make sure that I finish within time also. Yeah. Okay, let me share my screen first.
Sir, your screen is already visible for all of us. Thank you.
Yeah. Yeah. So cloud security, right? All of you guys familiar with Facebook and Google Photo. This is one of the two free cloud storage we were provided. So Facebook, you can load unlimited number of photos. Have you ever noticed that? You can actually upload unlimited number of photos. If you have an account, you can just do it. Keep on uploading. Only thing you have to make sure that you should not be uploading anything that violate their rules and regulation. If that violates, sometimes they might block you, right? And recently, this kind of incident happening a lot, and people are losing their account because of that. So we'll talk about that part also, like why they block sometime because of some content you have. Second thing, you have Google Photo. Google Photo will give you approximately 15 GB, I guess. Currently, it is giving you. So that means that includes your Google Photo, your Gmail, and all the. So now, when you want to upload a photo, then you just need to log into Google Photo, and then you choose there is an upload option, and you upload a photo. While uploading, it will ask you whether you want to upload the image as it is, or you want to upload in the Google format. So Google format will reduce your image size, compress a bit, and that way you can load many images. But how many of you actually ever notice that the photo you are uploading, it is also visible to Google people? and the photo you are actually uploading to Facebook, that is also visible to Facebook. Sometime, like, yeah, we being teenage and all teenagers, right? So during teenage time, I also remember, so we upload whatever we want, right? And there might be some images which is private to us, but we expect, we do not have any clue that whatever we are uploading, it is also visible to the cloud owner. Here we are talking about the cloud owner is Google or Facebook, and this way you can have any cloud owner you want, right? So, for example, you have medical record that you don't want to share with anyone. For example, you have a bank account, images of your bank statement that you want to upload so that you can preserve it in Facebook or Google. But unfortunate part is Google can see it, and they have model actually whatever you are uploading, whatever image you are uploading, they have a model to precisely figure out what is this image about, right? And based on that they
Excuse me,
can
sir.
categorize your, yeah, please.
Sir, the screen is not visible. Could you please reshare? Yes, sir.
But I logged in with my two, one my mobile, one with laptop, but in my mobile it is visible, I guess. Can you please recheck? Because
I
now,
also, we are also logged into two devices. I just cross-verified that it's not visible in the other device as well. Can you please reshare?
okay, let me do it again.
Sorry. Dear participants, is it visible to you, or is it some network issue from my end? Not visible. Thank you, Rashmi Ranjan, sir. Thank you. Yes, thank you. Sir, kindly reshare. Thanks.
Yeah, it's going on. What about now? Can you see it now?
No, sir. No, sir.
Yes, sir. Can I see, sir? But on the top of the there are some Zoom platforms you are saying, right?
Yeah, so that I can hide, it will go away.
Yeah, hide that platform, sir. Then the all participants can see your screen. Sure.
Yeah, now it's visible, right?
Not exactly, sir.
Yeah.
Sorry. Yeah, it's visible now. Now
I
it's
don't know.
perfect. No, sir, ho gaya. It's done. We got it. You are on the content slide. Please go ahead, sir. Thank you. It's visible to everyone, sir.
Yeah. So these images are not private to you, because this cloud service provider, they can also see, they can use your data as per their requirement. When you create an account in Google or Facebook, you see the terms and condition. There are certain condition. I remember when I first time created Facebook, it used to say that whatever content you are uploading, Facebook is going to have the ownership on it. Right. So that means whatever images and all, it will have its ownership, and it can use it as per its requirement. Only thing they claim that they will maintain your privacy, but actually not. So nowadays they do lots of analysis on the uploaded images, because now what we can do, like whenever we are traveling, whatever achievement we are having, whatever incident we are having, everything we upload, right? And that is like full-fledged information of a person, and that goes to this cloud service provider, and they use it for their different purpose, for their political motivation, for their business motivation, for their personal interest. Everywhere there, I mean, like everything is related to finance, eventually money and all, and they're going to use it. So suppose you are a quite decent, mature person, and you don't want that your privacy should be violated by Facebook or these sort of cloud service provider. You want to secure your data. So one solution you could do is that whenever you are uploading your data in the Facebook or any sort of cloud service provider, you should encrypt your data. Now, the problem is this encryption is, when we talk about encryption, right, you are going through different security talks and all. So you must be familiar with the term called encryption and decryption. So if you encrypt your data, so nobody can see it, right? Nowadays, we have a great encryption technique. If you encrypt with that technique, so only you can decrypt, none of the other guy can decrypt it, so they cannot see what is there in the data. Now I'm going to talk about why you cannot use this sort of encryption decryption technique in specifically image related application or computer vision related application, and why you try to do something called uh, encryption technique which is suitable for AI applications. And if you do that, there are few issues. So basically, my talk is all about AI related encryption technique, right? Normal encryption technique is basically based on cryptography. That is a mathematical technique, right? We can also do encryption using AI model, machine learning model. Right? If you use this encryption technique, you'll get a lot of benefit. One of the benefit is that you can actually your model can work on encrypted data. That is the key advantage. But if you use cryptographic encryption, then your machine learning model is not going to work on encrypted data. Now I'll talk about why you need to have a model which worked on encrypted data. I'll come to that part later. But anyway, this is what the requirement. You need to have an encryption technique where machine learning model can work on the encrypted data. That is a key part. And the similar thing is also there in cryptography. We call it homomorphic encryption. But right now, the homomorphic encryption, whatever we have, that is also based on machine learning technique. If you want to apply this homomorphic encryption to be used for machine learning application, then there are the technique available that is also machine learning based, not purely cryptographic based. So if you take pure cryptographic based homomorphic encryption technique, so that is not going to work on machine learning. So there is a trade-off, right? So here are the content of my talk. We briefly introduced about this encryption technique and what its requirement, motivation, objective. Then I'll talk about uh, some of the existing technique we have. And then I'll talk about one of our interesting work that shows that the vulnerability of this existing technique. Actually, this technique we have, it can be easily, you can break it, right? Our technique will show how to break it. And now that means what you feel that your data is encrypted in the cloud, but actually the cloud people can decrypt it and by following our something similar technique, and it's not maintaining any privacy right now. So yeah, finally I will conclude on this. Let us move on. Right now I'm in introduction slide. I hope you're able to see this line called what is neural network. Right? So let us first talk about neural network. This is not a cryptographic talk. This talk is based on machine learning and how we can use machine learning to encrypt data. And right, once you have this encryption technique, then how you can use this encrypted data to actually use for different machine learning application, other application. So when we talk about neural network, right, it is basically, you can think of it as a graph where individual nodes are neuron. And in a graph, that doesn't have any, it's like you can start from any node and you can end to any node, right? But in neural network, the network we are talking about, so that is a specific sort of network. Generally, that is the concept based on Boolean machine, where you have a fixed sort of nodes which are considered as input and a few fixed set of node which will be considered as output. So, and there will be data flow from the input to the output. And yeah, so the kind of network we will be talking about, it's convolution neural network. So convolution neural network is based on convolution operation, that is a mathematical operations. Basically, I'm not going to go detail into all this mathematical operation. Rather, I'll give you some highlight. For example, if you perform convolution operation. So in order to perform convolution operation, you need to do certain filters. So we call it image processing filters. So you can apply those filters to extract certain information from your image. And this information is called as feature. Okay, certain characteristic of the image you can extract using these filters. For example, edge, shape, texture. These are certain pattern or characteristic or features of an image. And you can use different filter to extract different features. Okay, so CNN can learn this pattern quite well, and it has got wide application. For example, face recognition, you have application in self-driving car. You know, if you see self-driving car, it is full of convolution machine learning. Initially, they used to deploy, right? And nowadays, they have n numbers of sensor also. Together, it works and guide the uh, car to make its proper decision. And medical imaging was, I would say, this is the key application that revolutionized your machine learning domain or image processing domain. So because you see medical imaging, the MRI data, the different sort of, for example, this your endoscopy, your X-ray, all these images can be taken, and you can apply different image processing technique, or you can apply machine learning model to analyze the data and extract certain information the doctor wants. Okay. So, for example, to our neural network, this is the image, right? Image of an elephant. I hope all of you able to see this particular slide with image and right hand side with lots of numbers. So this left-hand side, what you see is a human. So as a human, we see it, right? But to a neural network, this is nothing, or to a computer, this is nothing but a set of numbers, right? So if you see, this is certain numbers of pixels here. So individual pixel is represented by 3 bytes. So individual pixel is represented by 3 bytes. Suppose this is a grayscale image. Grayscale means black and white. Then 1 pixel is represented by 1 byte. So this 1 byte value could be from 0 to, if we consider it's only positive value. So 1 byte value, that range is from 0 to 255, right? So, and depending on the, depending on the intensity of the pixel, so this value changes, right? So now you can see this different values representing different pixel of this images, right? So to a computer, an image is nothing but this numbers. So now how this image is seen by a computer, it's basically a grid of pixels. It range from 0 to 255, and if you have color image, so then it will have 3 channels. So 3 channel, you can imagine. So instead of one such grid, you have 3 such grid, 3 such metrics of value, or 3 such 2D array of integers. So that is one for red, one for green, one for blue. Okay. And this is another grayscale representation. You see how the values are varying, and the resolution of this image is not so high, but if you are using any laptop or mobile phone, you can zoom in the image and you can see the values. So this is just to show you how this different, light intensity, each square is a pixel. Different light intensity is representing different values in grayscale. This is in the grayscale format. So let us move on. So this is a RGB image. This is a color image. So if you consider one particular pixel here, so that has got 3 value, right? So again, these 3 value, each of them will lies from 0 to 255. So this is what are image to a computer. So now what convolution operation is, basically you give an input image, and this input image is converted into different channels. So actually one particular 2D image, or you say 2D array, this is nothing but some values, that value extracted from this image using one particular filter. So you can think of this is 28 cross 28 matrix or array of 28 cross 28 integers. So from that array of 28 cross 28 integers, I'm generating 24 cross 24 integers here using one particular filter, and I can have n numbers of filters. So I'll have this n such 2D array. Okay, so this is a 3D representation. So it will have 24 cross 24 cross n. So n decide how many channels or number of filters you have. So in each iteration, this is one iteration, you will get this set of channels or a 3D representation, right? And then that passed on to the next convolution layer, and this way it continues. At the end, what happened? All this 3D representation are flattened. Flattened means we convert from 3D to 2D. Those who knows Python program, you know how to do convert from 2D to 3D or 3D to 1D. So basically we are converting into 1D, that is 1D array. So this 1D array is passed on to this fully connected network. So this fully connected network is nothing but a set of neuron, right? So uh, one neuron is nothing but it's basically a neuron operation is nothing but a weighted sum, and weighted sum, linear operation, a1 x1 plus a2 x2 plus a3 x3, that is weighted sum, right? So you perform this weighted sum. So you have this input and it will have a weight here. So weighted sum, this input is x and this weight is a. So a1 x1 plus this one will have a2 x2. This way you'll have all the inputs multiplied by their weight. So weights are the constant. In this case, like in the linear algebra, whatever we studied, there, in that sense, x is the input and a is your constant, that is the weight representation. And that weighted sum goes as an input to a uh, uh, to an activation function. So that activation function is nothing but it decides a threshold based on which the output is generated. For example, if it is beyond certain value, output will be generated. If it is not beyond that threshold, then output will not be generated. So that is like a triggering mechanism that is actually there in human brain, and initially that was being replicated in neural network, but nowadays we don't use that sort of activation, rather we use sort of linear activation, right? And linear activation means whatever value you have, corresponding to that value, you will get an output value. So output is not only 0 or 1, rather output will also be a continuous value. So anyway, you can get to know more details on that. But what this two layer of neuron does is that when whatever this particular data you are getting, that is a high level feature representation of this particular input image. So we call it semantic feature representation. Semantic feature in the sense it here in this particular handwritten digit, you can think of the structure of this digit. That is the semantic representation. So that will be preserved in this particular feature vector. We can also call it feature vector, which is a flattened one. And that if you feed to this neural network, this is pure neural network, and this part was convolution. So what happens? It can actually work as a classifier. So these are red one is the classes. So 0 to 9. See, for example, this is a digit 2. So it can take that input and it can classify it as a 2. Okay, so this is what how your neural network works. I'm not talking about the training part. So there are ways to do training here. Those who are into machine learning background, they know how to do training. But this is overall convolution network. Now let us look into the face recognition part. Suppose there is a face recognition system you want to deploy in your cloud. For example, you have a shop. Say you have a company or you have a shop or something which you want to monitor, right? Who is there in the shop, inside the shop, or who is working in the shop. So for that, you deployed a camera there. And now, and a runtime you are monitoring who is there, the person is known or unknown. Okay. So that means your camera only capture the images. Then you need a machine learning model to actually recognize that face and classify it. Recognize in this face, that means whether it is Subidali or not. Right? Okay. So that means you need a neural network which will take the image, extract its features, and then it will say, okay, it is Subidali, or it is Pravan, or it is Shravan, or it is Rajesh or Rakesh, whatever. Okay? And suppose you have 5 employees working in your you hired, and it is then your output should have 6. So 5 employee, the name of 5 employee, and the sixth one is unknown. So the moment it flags unknown guy, then it should generate a trigger to your mobile phone that some unknown people is there in your shop. Then only you will go and check your camera and figure out that who is that unknown people, whether that is a thief or so, right? And then accordingly you will take your own decision for that. So face recognition model has got wide application wherever you go nowadays. Everywhere they are taking your facial data. So facial data, it's called fingerprint, right? For example, you use your mobile phone has your facial fingerprint, and it take your facial image, and based on that it unlock your mobile. So now it's basically, if you see this face recognition system, it is basically a deep neural network with convolutions, deep convolution neural network. So it takes an image, and in output it generate which class that image belongs to. Okay, it matches with one of the face. Okay, in the output, see in this case, the output has got 10 different classes. So if you give the image, if it falls into one of the classes, you will be matching with that particular class. So So in this particular example, so this face is corresponding to the identity called Lena. Suppose the lady name is Lena, so it will match with that particular label. Say that Lena is corresponding to the label 1, so it will be matching with that one. And this way, the model recognize the faces. So now, if you see the feature extraction, it basically to the model, it is just a number, right? And through this number, they will extract the pattern surrounding a particular region of the image, right? So, and now through that pattern, you can actually highlight some region. You see, some region are bluish, some region is yellowish, some region is reddish, because you are following RGB. So then certain combination of number will give you certain colors, right? And this way you can actually see lots of high level initially feature is here, and that is gradually getting into low level, right? And so finally it goes to this fully connected layer, and this fully connected layer will take it and figure out this pattern. Does it have a pattern of a particular class? Okay. So now, whatever talk we are also discussing here, see, this talk is about security, right? So we should also talk about the security of machine learning model. So I talk about a machine learning model called face recognition system. So suppose you train the face recognition system on your face. So the moment you give any image of your face, it will detect it is you, right? So for example, I train a model with my faces. The moment I give any image, it will say it is Subit. And any other image, if I give, it is say the other one, right? 0 or 1. So it is 1 means Subit, 0 means not Subit, right? So this is a classification model. So face recognition is also a classification model. And now I'm going to talk about adversarial machine learning. That is an attack on this particular face recognition system. For example, suppose you train a model with this sort of animals, right? So now, so this is a panda, right? So, and are you familiar with this gibbon? Gibbon is also a panda-like animal, but in the shape and size, it is much more smaller than panda. Okay. So what I can do, suppose the model is trained on panda. So if I give this panda image to a model, it will correctly predict it as panda. But what I can do, I can actually introduce certain noise into this particular image. And see, this is what the noisy image. Okay. If you give this noisy image to the same model, it won't say this is as panda. Rather, it will say it is a gibbon. So you can just Google, if you have mobile phone with you, you can just Google that panda, difference between panda and gibbon. You can see the Google will throw the image of panda and image together. So gibbon is sort of very tiny, a little one than panda. So what is happening here? By adding this noise, I'm actually fooling the model to predict it as a panda. So I can add this noise in such a way that your model will tell you this is not panda, rather it is a tiger. Whatever I want, I can do it actually. So this is called adversarial machine learning attack, right? So in adversarial machine learning, what we do, we actually try to fool the model. So for example, you have a Tesla car. So Tesla car, what it does, how it make the decision. One of the key decision making process earlier was to use a convolution neural network. So it takes the roadside image, roadside symbol image, and suppose the symbol image is written as 100 kilometers per hour. Then if it see there is no barrier in front, right? So road is totally open, no traffic, so it can go up to 100 kilometers per hour, right? Because it just got the symbol and the speed limit is 100 kilometer hour, and the road is kind of traffic less, so it can go up to 100 kilometers. This is interesting highway. So now what I can do, actually people have done it. So I can take this sort of noisy film, okay, and I can put it on the roadside symbol, and then which symbol I can use? I can use a stop symbol. For example, that stop symbol, somewhere you'll see a stop symbol. So I can put it on top of the stop symbol, and I will design this perturbation in such a way, this noise in such a way, the model will fool it as 100 kilometers per hour. What I meant, let me reiterate. So what I meant is, suppose there is a roadside symbol that is a stop sign there. So the moment Tesla car retrieve that symbol, it should stop, right? Now, I'm being an attacker. I can go and I can put a film on top of that symbol. It would be visible. That perturbation won't be visible because it would look like certain dot. You see, this perturbation is added to this image. The image doesn't change much. You can't see. This is a perturbed image. You can't see the difference. So similarly, I put similar perturbation on the roadside symbol. Now the stop sign will go to the perturbed image. The Tesla car clicked that image right through its camera, and that goes to its model, and the model will fool, and it will label it as 100 kilometers per hour. Then you can imagine what happens. Then it will crash into something, right? And there might be a big accident. And this was happened even with Tesla car also. So this is what adversarial machine learning was. So what I will show you, people actually use adversarial machine learning technique in a constructive way in cloud security. So what is the constructive way? People use adversarial machine learning technique to actually encrypt the image so that uh, human cannot figure out whose image is that, right? So you can hide the content. For example, you want to upload your image somewhere. For some application, say there is a machine learning application that checks how beautiful you are, right? So it will give you a score from 0 to 9, okay, and you want to give your image so that it will give you some score 0 to 9. So you want to participate in that competition. So now you also don't want that you are a teenage girl and or teenage guy and you don't want your family to know it, right? But that means you should not be giving you exact face. Your face will be perturbed. It is not visible to common people. So if it is given to any guy, he will not recognize that it is your face. But if it goes to machine learning model that gives you the score, that machine learning model will work perfectly, right? So previous example, adversarial machine learning, that was a ulta application, opposite application, where I perturb the image in such a way so that machine learning model fail, but human will not fail. But here we are doing exactly opposite. Here we want the human will fail. Human will not be able to detect that image, but the machine learning model will be able to do its job, right? So this is called facial privacy. Facial privacy in the sense, so you upload your image, but nobody will able to recognize who's this. So many time you see, like in many applications, people blur the face, right? Just to, for example, some crime happen, and then people police capture the suspect, right? And as they were suspect, they were not decided as culprit by the court, so they were suspect. So what they do, if you have video, the face will be blurred, right? So that is also one of this application. So that person who clicked the picture, he don't want to disclose the face of the image, so you can use this particular application to do that. So what this particular application work, for example, this is the original image that goes here to particular model. And yeah, okay, this is a different one. So yeah, this is again one of the other requirements. So this is, so what I just discussed. First thing, I spoke about convolution operation, right? That is one of our requirement, background requirement, in order to understand our work. Second thing, I discussed about adversarial machine learning. Okay, that is also one of the requirement to understand the work. And third thing is generative adversarial network, GAN. So nowadays, GAN is pretty famous generative model. You guys are familiar with ChatGPT? That is also a generative model. That is not exactly GAN, that is based on transformer model, right? So that is purely used in language sort of applications, text application. But generative adversarial network majorly used in image related application. For example, you want to generate new images, so you can use generative adversarial networks. So so basically it's basically one of the convolution model which is trained on some given image. Suppose you have uh, suppose you are in a company, and you want to do analysis on the people working here in your company. For example, nowadays there is a great application of machine learning in the study of psychology, right? So, for example, psychiatrists and all this application could be useful to psychiatrists or the people who working in the psychology domain. So, what this model can do, this actually it can predict your current psychology. It can predict your emotion. All this feature it can extract from your face. But suppose in your company only have 10 guys, right? And this 10 guys data you have, okay, sometimes they were sad, you click pictures, sometimes they were happy, you click their picture. And this way you collected maybe 1000 image. But this 1000 image is not sufficient for any deep learning application. So you need at least 10,000 or 1 lakh images to perform an interesting uh, training of a model, right? And that once it is trained, then it will give you interesting application. So in order to increase the number of image, what you can do, you can train a generative model. Okay. So this is called generator and this is discriminator. So this generative model you can train, and so that late it will be trained on this images, and later on it can generate similar images, right? So see, this image is generated. This will have lot of common feature of these guys, okay, on which it got trained. Now, if you see how it trained, it's like uh, initially you give a random input, and this model will generate some random image, okay, and that it goes to some guy. It is something similar. Have you seen any movie of talking about crime scene? Some crime happen, and then police do not have clue who did the crime, but there is one guy who actually saw the criminal. Okay, he was the witness. So then police take him to a painter, right? Police take him to a painter, and that painter will paint about the culprit by asking this guy, right? How is most, did he had mustache, did he had beard, did he had eyes like this, like that, and keep on asking and asking for whole day. He'll be talking to this guy, and eventually that painter, who is supposed to be expert, he will come up with the painting of that culprit, right? I hope you have seen this in movies. So this generative adversarial network training is something similar, right? So it will generate some image, right? And this guy is the witness. He has seen a culprit. So all these images you have, you imagine all these are culprit. Okay. So now this generator has to generate, he's a painter. So he has to generate image like this guy. So image having features, maybe this image matching with the eyes of this one, lips of this one, and maybe nose of this one, something similar feature of this guy. All right. So each time it will generate some crap and ask this guy, is it matching or not matching? So when it is matching, it will say real. When it is not matching, it will say fake. Okay. So now each time it says fake, that means not matching, it will change itself internally so that it will give a better image, right? And this continues, keep on continue, and like the way the painter will paint the original image of that person, and which would like at least there would be 70-80% matches. If the witness has got sufficient memory about that person's face, then the painter can recover the person's face as an image from that witness, right? Something similar technique applied here. So this is called generative adversarial network. And GAN is pretty famous, widely used. So what is happening here, if you want to understand, is that this images has got a facial distribution. So those are mathematical guy. If you are mathematical guy, you can understand my point now. This face, for example, I just consider the nose, right? So different people have different noses. So here, say I have 1,000 image. So 1,000 people will have different types of nose. And what it does, so each this nose has got a particular distribution, right? And one guy's nose means it is one sample of the distribution. But I do not have the knowledge of the entire distribution, right? But what I have few sample of those distribution. So what I'm trying to do is to learn the distribution from this sample. This generator try to learn the distribution from the sample. If you learn the distribution, then you can just give a random input. This is just give you one sample out of the distribution, one random sample. This random noise is nothing but asking the generator to give me a random sample. Okay. So ultimate job of this generator is to learn the distribution of this particular images, set of images. So if you learn it, then you can generate any image which has got a feature like these guys, all these guys. Okay. So yeah, this is about a generative adversarial network. That is the third part that we need for our analysis. So now you see lots of image you need to train a generator. So first this image goes to discriminator, and discriminator will understand which one is real. Real means real image, and fake means generated by this guy. So these are fake images generated by generator. This was not original image. So now this image goes to this guy, it should flag it as a fake, and whenever this image comes to this guy, it should flag it as a real. Now the moment this generator figure out कि discriminator flag it fake, it will try to generate in a better way, so that eventually ultimate job of the generator is to make sure that discriminator flag its image as a real image. When that thing keep happening, then you consider that your generator got trained. Okay. So this is how actually image generation through generator happens. Now let us talk about the encryption part. So in the encryption part, we have a generator in place and convolution operation for different machine learning application. One of the application is face recognition. So suppose you have your cloud server, local server, okay, and in the local server means your computer. So you have all your image, you encrypt your image, and then you upload into the service. You upload into the cloud, okay, but you encrypt it in such a way so that in the cloud you have this face recognition system. See, we talk about that face recognition system that you deployed in your job place, but that where is that particular model running, that face recognition model running? That must be running in somewhere in the cloud, right? So it should not be running in your mobile phone because your mobile phone is pretty tiny. That may not be that useful to run this. Nowadays it is possible, but earlier it was not possible. So then generally people use the help of the cloud. They deploy the machine learning application. We call it service model. In our case, the example is face recognition system that is running on cloud. So that means this cloud is taking your data from your shop through the camera, and that camera data is going to the cloud, right? So that means cloud owner is also getting the feed of the camera. For example, through nowadays there are like 2000 3000 camera is there, right? You can buy it and you can connect it with your mobile phone, and you can watch it from anywhere in the world if you have the internet. But you see the problem with this camera, you know that. So this data goes to their cloud first, right? Most of this camera are cloud based. So they'll ask you, you do not install a memory card, rather you install the data in the cloud. So they are earning majorly from their key cloud services, not by selling the camera, because the camera price is hardly 2 3 thousand. Next day what they charge you, the storage price. Okay, so that is the ultimate job. So now actually data goes to the cloud, so that means you can store even 100 days of data in the cloud based on how much cloud storage you bought. And now in the cloud, this cloud service provider will also give you a lot of feature, right? For example, face recognition system, it can detect who is the guy, who is a known guy, unknown guy. It can runtime monitor also if some incident happened. For example, you have an old man in the house. If he just fell, so it can detect. So all these services will be there, and he will be happy to get those services, right? Suppose you have old people in your house, parent, maybe grandparents are there. You want to look after. You are there in office. You want to make sure they are well and good. So now if they fell down somewhere, so you just want to get to know that this something happened and something triggered. So your mobile start beeping because some incident happened. So that services is running in the cloud. Now, first thing is the cloud service provider is getting your data and then doing some analysis through machine learning model and giving you some feedback or some analytic data. So now I don't want what I want to encrypt the data before sending it to cloud. So this is my camera data and this is my encryption model. And after encryption, it goes to the cloud. Okay. Then it goes to my face recognition system in the cloud. Now face recognition system should work on this encrypted data. This encryption technique is to protect from human, not from this model. Okay. So that means that guy won't be able to see who is there, right? What dress he is wearing. Okay. All this information, personal detail will not be there. Only thing, whether that person is Subidali or not, that yes or no answer will be there. Okay. So suppose this is what the application is there you want, and then it will say this is what client one, this is what client N, client two, client three, something like that. Okay, so this is how the framework is there, and you want such an encryption technique. So first we'll talk about encryption technique, and then we'll see what is its vulnerability. And later you have the cloud data, and you want to see who are there. Actually, you figure out some person is there, and who is that person. So you should be able to decrypt and see who is that person, right? Cloud people should not be able to see, but you should be able to see. So you should be having a decryption algorithm also. So that is why you decrypt it. So here you should have a key through which you encrypt it. And as you have the key, cloud people doesn't have the key, so they cannot decrypt it. Similarly, you have the key, you can decrypt it. So this is how the encryption works. But let me tell you, this encryption is not cryptographic encryption. If you apply cryptographic encryption, then this service model will not work. This face recognition will not work. So in cryptographic encryption, they completely randomize your data, right? So if you consider a cryptographic algorithm, so those who are from cryptographic, they know cryptographic encryption technique are pseudo-random number generator kind of. They actually work as a pseudo number random number generator. So that means whatever output you're getting, that's a random one corresponding to the input. So yeah, now we'll talk about how this encryption works using machine learning techniques. So you have an image. So now what you can do, you want an encrypted image X prime. And that encrypted image, if goes to service model, the service model will work perfectly. So that means what this service model does, they extract feature from the image, and that feature goes to the fully connected layer I talk about, that fully connected neural network, and then it classifies, right? So you extract feature, that is 1D array. This is the 1D array, right? So now this is what the encrypted one. So if it goes to this model, it will also have a 1D array. But if if the encrypted image should work for this model, then the two features should be similar, right? This feature and this feature should be similar. That is the first requirement. If you do such a randomness here that this feature and this feature are different, that means you give Subid's image and then again encrypted Subid image, and this become randomized. And then this feature are not matching with this one, then this model will not tell this one as Subid image, right? So the feature should be preserved. Some feature which is needed by this fully connected layer, that feature should be preserved. That is the first requirement. Now, so how do we make sure that the difference between these two will be calculated? So we call it loss function, L1, L2 norm. So L1 means just the difference. L2 means square difference. So we will use certain loss function to figure out the difference. So what we try to do, whatever we are doing here, the encryption should minimize this loss. Okay, so you should not be, this value should not be much more away from this one. Now, second thing, you need another model so that this encrypted image should be able to decrypt, right? And this is the model who is giving you this image. So that means this image you feed into this model and this should produce the original image, right? So that means the output of this model and the original model, so the difference there, that should be minimized. So this original image coming here and the output of this key model coming here. So this is again a loss, LG, that is generative loss. So this is a GAN actually. This is a GAN that takes an encrypted image and generate the original image. So this is a GAN. So now the loss between, initially this is, you have to fine tune a bit so that it should produce exactly the original image from this noisy one. Okay, and how you make sure that? By reducing this loss. So now this is the second thing. Now, how do you encrypt it? This is a generation part. First one is so that the encrypted image should work for the machine learning model. Second thing, the encryption should also work for the GAN so that it can recover the original image. Third thing, how do you encrypt it? So how do you encrypt it? For that, we actually induce certain perturbation into the image. We induce in certain perturbation in the image so that this visual content is lost. Visual content is lost in the sense human eye cannot see the visual content. So you cannot, from the picture, whatever noisy picture you'll be getting, from that picture, you'll not able to see who is there in the picture. So for that, we will add certain perturbation. And what sort of perturbation we'll add? Adversarial perturbation, that AML, adversarial machine learning I talk about, that sort of perturbation we'll add so that this model will work here. But to human eyes, it is indistinguishable from the original image. So now we'll consider optimizer. So we'll perturb the perturbation in such a way so that this three loss together will be minimized. So I'll give it to this three requirement to optimizer, and I will ask to perturb it such a way so that this thing can be minimized. So the optimizer will do it. In machine learning, we use optimizer called gradient descent technique, and the gradient descent technique can do it. And then what happened? You'll have this perturbation updated, and then for each image, you will have a perturbed image so that this perturbed image will work for this model. If goes through this one, it will be giving you original image. But if you see that image, you cannot recognize any guy is there or not. Okay. So then visually it is secure. So from that image, nobody can say who is there in that image. So this particular encryption technique is used to protect the visual content. So I'll stop for maybe for questions. So far, if you have any question, you can ask now. Is there any
Yes, sir.
question?
Yeah, I have a
If
question,
you
sir.
have,
It's
you
the same
can
image. The same image
just
can be used to by the server to decrypt it, right? What we are
your voice
after
is cracking.
considering, after you have created this disturbance in the image, are you able to hear me, sir?
Voice is cracking. Yeah, now it is
Hmm.
better.
Yeah,
Can you repeat it?
actually, you are creating a new image with a noise, right? The disturbed image. It can be used
Yes,
by
yes.
again the some of the, I mean, the server, and then if they are interested, and then can't they change it?
They can change it. If they change it, then what is the point of changing it? I mean, what is the motivation behind it?
I mean, they can convert into the original one like hackers do. They can prepare the original image, and they
Okay,
also
so
can
for
have
that
the
you
access
need
to
this
that.
one. For that, yeah, you see this particular model. This is the key, right? If you don't have this model, you cannot generate them. And then this guy who proposed this technique, they mathematically, I mean, empirically, they prove it that if you don't have this model, you cannot generate this one originally. So you keep it with you. You means you are the owner of the image. So you, before you send your camera data to the cloud, you pass you encrypt it and send it to the cloud. And you don't need to load this one in the cloud because cloud don't need it. You need it personally. So whenever you need it personally, download the cloud encrypted data in your machine and you apply this one and you can decrypt it. Right. So that is what their framework or the attack defense scenario, defense assumption and all. So you will keep it in your local machine. You will not upload this one in the cloud. So nobody can see this, have access to this model. So if they don't have this model, they cannot decrypt it. That was the security, right? But you were correctly pointed out this thing. So this particular security mechanism has got vulnerability. So I will talk about this one. Uh,
Vulnerable. It is
yeah,
vulnerable, then it
yeah.
will
So
be.
what we so we can actually learn this particular model, right? So that is what key
Yeah.
limitation of this sort of cloud encryption. Any other question?
Yeah, there is another question, sir. Actually, I have done a small paper on, Twitter analysis is very common these days.
Yeah, yeah.
But that time I learned that Facebook is offering lot of security and all, but still you have, you have claimed that they don't provide security proper. I mean, the images can be used by on the business and financial grounds, and then they can be tested on the Facebook. I mean, you told that the cloud what is used by Facebook or Google and all, they are still having some type of access. uh, is it only for the owners, or is it for the users, I mean common users, you mean?
See, if you ask any security guy, they'll tell you whenever you are uploading your personal data or secure private data in somebody else's computer, you should not trust that computer. Right. So that is the same thing I'm telling you. Facebook, see that computer, whatever cloud service you are taking, they will always claim that it is completely secure, privacy is secure, blah blah XYZ, so many security parameters they'll claim. For example, WhatsApp is end-to-end encrypted, right? So they'll keep on claiming advertising that nobody can see it. But do you believe it? You ask any security guy, they'll say nobody believes it. Any security expert you ask, is WhatsApp end-to-end encrypted and nobody can see, including Facebook can't see it or Meta can't see it? They'll say,
Mm,
I don't believe that. Same thing I'm telling, I
mm,
don't believe it. I'm not claiming it is, they are telling lies and all, but I don't believe it.
mm.
Right.
There is some
So
glitch in it.
then
Get it.
there are hundreds of reasons why this expert don't believe it. First thing,
Mm,
the data you are uploading, they need their own business analytics. They need their own advertising mechanism, advertising analytic, and for that they need your data, right? And they claim it
yeah,
fine, but they also leak it. And this Cambridge Analytic leakage, that is one of the
mm,
reason why people don't trust Facebook. So just Google for Cambridge Analytic data leakage. And it just 3-4 days back, you Geo and all, right? So the mobile service provider, you also trust them. They also have their cloud. And you see, just 4-5 days back, all the Geo data got leaked. I mean, like now everybody knows your. I mean, like anybody who wants your Aadhaar card, if I just need your phone number, I can tell you what is your Aadhaar card number, because that all these detail are leaked now, right? I mean, somebody just leaked it and uploaded, and they'll even provide a provide a link to their
So you mean
server very.
if I enter some mobile number now in the Google, I will be in a position to get the Aadhaar card number for that person?
No, no, not Google. Actually, somebody hacked into this Geo servers and even Airtel
Okay.
server, and they
Oh,
just extracted, leaked all the data, personal data.
okay,
For
okay.
example,
Yeah, yeah.
I just check, I give my phone number. My phone number is there with one of you. And then I put my phone number and it give my Aadhaar number, my address in the Aadhaar number. Even it was giving me my father's name, right? And imagine that data is public now. Now closed their this guy closed their that portal. Now this portal is not working because maybe lots of
Okay.
government directive are coming up, right? This is illegal.
Yeah.
So, but just 4-5 days back, it was working, right? So now it is
I
not
got it.
working. What will happen? They will ask you money. You give them money. Every now and then you get a call from some guy asking for loan and all, right? How do they get to
Yes.
know your number? Like this only. Now the same guy who used to scam you will come and say, "This is what your Aadhaar number, and this is what your father's name. I'm calling from bank. You need to give me this one."
Exactly.
See,
I got it.
so
Lot of
so
credit.
so don't trust all this organization. See, ultimate their job is to earn money, and data is the oil nowadays. Like our honorable prime minister told few days back. Nowadays, the data is the gold, right? If you have the data, so you can do anything with it. So yeah,
One last question, sir. There has been always like whenever we try to access the cloud, there's a part or some online service. They will say partial access, or you want to share full your information in full. So, or when the app is active, what is the meaning of that? How's does it have any?
that is access to your
Uh,
mobile phone or your laptop desktop, right?
uh,
So that you should never give, because the moment you give, so whenever whatever you upload in your particular drive
Yeah,
or in
but
your
Google
mobile
also
phone.
asks when I'm storing like Google Drive, or you have Google Photos, they also ask us. Recently,
Yeah, because
two things.
they ask it to automatic upload, right? But yeah, so
Yeah,
that is pain and gain together, right? The gain is like it's automatically uploaded, and the pain is that they are taking all your data. Even if you don't
yeah,
want, automatically it is getting uploaded, right? So even if you deleted something, it is also be with them. So
yeah, because
yeah,
they are
so
saying full access only. They are not allowing for partial access.
yeah.
Even though I say partial access, they
Yeah,
won't
there are
agree.
some
They will
app
not show
they
it.
will restrict it. Yeah, some app they'll restrict that this is partial access is not allowed. Even the camera, nowadays this CCTV camera, 2,000 $3,000, they'll give you mobile app, and through app you can see the camera from anywhere in the world through internet, right?
Yes.
So it will also, if you want to store the data in your mobile phone, it will ask you to give full access. The moment you give full access, that means they can write. If they can write in your mobile phone, then they can launch a different sort of attack. They can also write a malware in your mobile phone. So the moment you start using this sort of application, so that means your data is compromised. And nowadays, see
Thank
the
you. Got it.
another controversy going on, right? With this government app or something. I forgot the name of the app, but you see, these are all like sometimes government themselves do it. I don't know exactly what has happened, but some government, I'm not talking about our country, but in different, if you go to China, government themselves, they do, continuous monitoring individual citizens, what they are doing, how they are doing, so that they can control people. So yeah, privacy is a big thing, but the responsibility of privacy is on us. It's not somebody else like Facebook. They'll give you privacy. You cannot trust. And there are hundreds of data leakage. I mean, not hundred, thousands of data leakage from each of this service provider. A few month back, even Gmail actually their user ID password that also got leaked. That's why they themselves notified user to change their user ID password, use two-step authentication and all. So this leakage shows that you cannot trust them. Yeah. So let us move on. So yeah, okay. So this encryption sort of encryption technique is known as perceptual encryption. So perceptual in the sense that given two image, we say this two image of a same person, right? So that is based on our perceptual knowledge, right? So this is the perception. So the perception based encryption is also happening. So where the perceptual data is getting lost. Perceptual data means now given this image, you cannot say whether this image is belong to this guy, right? So that perceptual information which is there, that is getting hidden. So that is why it is called perceptual encryption. So no, and the full form, the author named this encryption as adversarial visual information hiding. We call it AVIH. So AVIH was a pretty interesting, and this was published as one of the, there's a top tier conference, international conference on computer vision, ICCV. ICCV is a star conference. It's very tough to publish there. So now what happened the moment we see we security guy, we jump on it and we try to evaluate it. How much security is there, right? So, and then we figure out this variance consistency loss, the noise you are adding, it is not at all consistent, right? And you can actually get rid of it. And they claim that this GAN model is if you make it secret, then you cannot generate the original image, this one, from this one. Now, suppose I am a cloud guy. So I am a bad guy. I have my compromised cloud, and whoever upload any image, whether it is encrypted or not encrypted, I want to see who is there in the image. So that is, I'm that bad guy. So now what, I'm the hacker actually. So this guy is pretty challenged to me. He hurt my ego, right? So because he's now start encrypting. The moment you hurt hackers, right, that is a big problem, right? You should never hurt their ego. So then they'll apply all their effort to hack into your system. So suppose he hurt my ego and he uploaded encrypted instead of direct uploading it. So then I thought I'll teach you a lesson. Then what I can do, I will just show you how you can actually break into their system. So now this is the guy, and okay, let me just. So what I can do, my objective is to get that encryption key, right? That the model. So if I have that encryption key, then the data, encrypted data is with me now. You encrypted your data and you uploaded in my cloud. So encrypted data is with me. So only thing I need that the key is that model. If I can have that model, then I can actually decrypt your data, right? And that I will show how we can actually have that model. So the key model, they say key GAN, the original author of that encryption paper, they used to call that key as key GAN model, right? And we develop a technique where we actually train a GAN which become very generic, right? So you can think of this big key GAN we are developing. This key GAN can have information of all this small GAN. So I'll show you how we can do it. So first thing, what I have to do, I know your encryption technique. So first thing, see, in security domain, encryption technique is supposed to be public, right? There should not be any secrecy in the algorithm, right? So whatever encryption AVIH we have seen, that is a public. So I know it. So what I'll do, I will have my own encryption technique, own encryption mechanism, use that follows the same same algorithm, same AVIH algorithm. So I'll have my own data. That is my original data. So I'll take my picture, my parents' picture, and everyone, or I can download some images from internet and I'll just use it as my data. Now what I'll do? So now I'll use the same encryption method, but I don't have his key, right? I will use my key. Okay. So that means I'll have my own key again, and then based on that, I will get my encrypted data. Okay. This is not your data, but I have your encrypted data in my cloud, right? But I can use the encryption algorithm. Like, for example, you guys are familiar with AES, right? You are listening security talks. So AES is a well-known encryption algorithm. You can get the source code of AES, AES C program, AES Java program, AES Python program, and you can run that Python program using your own key so that you can encrypt your data and then you can decrypt using your own key, right? So same thing I'm doing. So I have that AVIH and I have my own key, and using that is the GAN. I have my own GAN and I can encrypt it. Okay. So this way I will collect a lot of original data and their encrypted data, and these are all my data. So we call it surrogate data, right? So next what I'll do, I will take some of this data and I will train one of the GAN, this GAN, okay, and I'll ask it to decrypt it. I have the data. I have the encrypted one and I have the original one. So I can train a model. There is no big deal. But if I did not have the original one, then it was difficult. But I have the encrypted data and I have the original data. So I can use a GAN or any autoencoder and I can give it to ask it to generate. So it can generate. So I can train a model GA. Okay. So similarly, I will train it in such a way so that this loss is called reconstruction loss. So this reconstruction loss, initially it will generate some garbage, right? So what I'll update its parameter, the model parameter, such a way so that this loss, the loss means the output and the original data should be minimized. And this way I will train the GAN. And then I will also train in such a way so that this feature loss, that means this is the service model. This is the service model. Feature loss also minimize. Okay. And this will give me, and this is what adversary loss. Okay. So this together will give me a particular model, this one. This is one such master key GAN. And now this is a very complicated training process. It took a lot of time actually. The training part take lots of time, but it works. Now there is one part I miss. Okay, I did not clarify. See this GH. Okay, the data here, it is not based on one key GAN, right? So in our experiment, I take one key GAN and based on that I generate or take original data and the encrypted data. This is one set corresponding to J. Okay. Then I will have 4 such J. So J equal to 0 to 3 I'll have. So I'll have 3 Gs. G0, G1, G2, G4. So what we had shown, ki if we have 4 such GAN, right, and you generate data from 4 such GAN, then using that surrogate data, you can actually do this one. So this part I missed it, so that's why I'm repeating. So now this is another GAN. So this can take all this encrypted data. So this encrypted data are from 4 different GAN models. GAN model in the sense 4 different key GAN, right? So you have 4 same encryption algorithm, but you run the encryption algorithm on 4 different data set and you encrypt them with 4 different key, right? So now you got 4 set of encrypted images, 4 set of original images, 4 set of encrypted images, and all these 4 set are based on 4 different keys. Okay. And now I'll take all this encrypted images and ask this model to decrypt it, right? So how, because original image I have, so I'll use this one. So this losses, and I will ask my model to train. Initially, it was very difficult. We tried different models. We start with autoencoder, it failed. Then we tried with their GAN only. but little larger than that they use. That is basically pix-to-pix GAN. If you are familiar with GAN models, so then you might be knowing pix-to-pix GAN. So they also use pix-to-pix GAN for this key. So in our case, it worked. And what happened eventually? So now this model is taking images from GAN 1, it is able to decrypt it. It is taking images from GAN 2, it is able to decrypt it. Like that, GAN 2, GAN 3, all the encrypted images of 4 different GAN key, it is able to decrypt it. Now my model is trained. So what I can do now, if my model is trained, I will take this model and I will take your data. Okay. Now these are all my data. These are all my data now. So I train my this particular GAN. Okay. Now I will look upon your data. So you have the encrypted data. So this I can give your encrypted data to this model and it will correctly generate. Now I'll show you the result. So so now this is what your encrypted data. Okay. And this is what the original image. And see, this is your data. I'm talking about your encrypted data. And through our GAN, I don't have access to this one. I just put it to show you that it can generate, right? And this is my model generated, right? This technique generated like this. And what I give it, your encrypted data, that is based on AVIH, right? And you see the quality of the image. And now in machine learning, how do you define the quality of the generated image? So there are a few things, LP plus, SSIM, cosine similarity. These are few metrics based on which you can actually compare this one versus this one, right? So you see this one versus this one. So cosine similarity is very high. So cosine similarity high means they are close to each other. So LP low means they are good quality. The quality are similar. Similarly, SSIM is high means they are good quality. So this way, again, this is the original image. This is their encrypted image. We were able to decrypt it. This is the original image. This is encrypted image. We were able to decrypt it. See the quality? And this is how we show that I just need 4 keys, okay, which I can do it. So I have the encryption algorithm with me. So I can write my code and I can implement it. Okay. So I just need to use 4 key and I encrypt my own data. So original data, encrypted data with key 1, original data, encrypted data with key 2, like that, 4 set of data, encrypted data. Now I can use this model to, to reconstruct the original data. That is on my data only, not your data. And once it is learned to reconstruct it, that means as it is learned to reconstruct encrypted image, which are encrypted based on 4 different keys, so it actually generalizes. That means it can actually decrypt from any key. So normally what happens in cryptography, if you want to actually extract the key, you need lot of keys. Like, I mean, for example, normally, generally, for example, I used to work in fault attack. In fault attack, at least earlier fault attack, you need at least 2 power 8 possible key. You should have, I mean, what I was suggesting. So in order to experiment, you have to try with 2 power 8, at least 256 different key you have to try. Then only you can break it using fault attack. That is the best known result. Okay. So, but here, using just four key, you can break into the system. Are you getting my point? So this was so easy, and we show that this defense mechanism is just kind of, myth. It doesn't provide any security because the security is based on the generative model, and the claim is there is that you cannot learn the feature that a particular generative model learned based on your data, right? Because those data set were different, and your mm, mm, data set is different. There is a specific feature of generative model. Generative model, the optimizer you use to train the generative model, that is basically optimized based on local minima. And theoretically, you can prove there are infinite many local minimas. Okay, so that is what their security claim. So one generative model, they converge or trained based on its own local minima, and there are millions of such local minima possible. So until unless you have the data, you cannot have the same local minima. But that is not true. This is what machine learning, right? Machine learning, it can learn. If you have the feature, it can learn, right? So that was a myth also. It's not like millions of local minima, but it can have millions of local minima, but their properties are also similar, right? So your model trained in one local minima, another model trained in another local minima, but the kind of pattern they are learning, those are similar, right? That's why you just need four key GAN, and using that you can train another master GAN, and that can actually extract this result. Yeah, so these are different results. If you are from machine learning background, you can understand. If you want to know more details, so see, this are the different the standard uh, classification algorithm, face recognition algorithm we tried. That is a service model we tried. And these are some of few more results. In all cases, we were able to generate high quality images from this encrypted image. So what we try to prove it, the technique they have shown is utterly vulnerable. It's not at all secure. It is just, like in machine learning, you cannot theoretically prove it, right? In cryptography, you can prove it. Machine learning, you cannot prove it. You just do empirical study. But when you do empirical study in machine learning, you also have a limitation. See, one training will take maybe days, right? So now imagine how many possible training you can do. But in cryptography, if you take one encryption model is given just a mathematical operation, some C program, and just less than a second, you can actually perform one encryption, right? So maybe in 1 minute you can perform hundreds of millions of encryption. So you can do lot of analysis, lot of empirical analysis in cryptography. But such empirical analysis is not possible in machine learning because your models are so heavy. So that's why the guy who proposed it, he did not able to perform all this analysis. And without this analysis, the claim was not right? And that shows the vulnerability. Yeah, later on, we extend this work. Recently, this work was published in IEEE Transaction of AI. That is also very prestigious journal in AI. It started recently, but it's picking up. And we did few more analysis on other different, encryption algorithm, AI-based encryption algorithm for different applications. And recently, our this extended work also published in PETS, privacy enhancing technique. That is a kind of A star or A conference. It's a very prestigious conference. So there also we perform similar analyses. And what we conclude is that this AI-enabled encryption are not at all secure. There is always a learnable parameter left over in the encrypted data, and you can extract those learnable parameter and you can train a model to recover the original image. So AI-based encryption are not at all secure. So if you want security, we suggest use cryptography. Now the problem with cryptography, so nowadays, I think people are coming up some homomorphic encryption that might be useful, but still, I don't have much background on that. Whether there are some cryptographic homomorphic encryption that will also work on machine learning model, but even if there that homomorphic, we also claim homomorphic encryption, but if you see that encryption technique, it is not purely cryptographic. Rather, again, they use some sort of shuffling. And if you're a crypto guy, you will see that this shuffling and all they are performing, that is not as per the principle of cryptography, right? And that can easily be broken. Yeah, so this is what my conclusion. So do not use machine learning based encryption technique to encrypt your data in order to load it in the cloud for having or to maintain privacy. use cryptographic technique, better you use you encrypt your data with standard cryptographic algorithm and load it in the cloud. Whenever you need to see that images, you download it, decrypt it. Okay? Do not use machine learning application. Yeah. So, and yeah, these are all my student. So the work I presented, that this Umesh is the lead author of that paper, Umesh Kashyap, and Sudeep Padi, he just submitted his thesis. He also contributed in that work. So we three worked in that this particular technique I propose. I present, and even more advanced work I was talking about that accepted in PETS conference, that is majorly done by Umesh. So he's the privacy guy in our team, and there are more guys. I majorly worked on this privacy, defect detection, and adversarial machine learning. And in hardware, another area that is my core PhD area, that is purely on hardware security, side channel analysis, and all. So for that, I have these two students, Om Saha and Pankaj Kashyap. Yeah. And these two are my MTech student. And this guy, yeah, this Jays works in LLM. So in LLM, this is again pretty famous domain nowadays. So, you can query LLM to give you, to ask how to make a bomb, IED, or how to do wrong thing, right? So, but Chat GPT sort of LLM, they have a, protection mechanism called guardrail. And whenever you give this kind of query, they will not answer you, or the way they answer you, it's not the response you are expecting. Okay, so the defense mechanism they deploy is called guardrail. So recently we wrote a paper and we submitted to PETS only, and there we show this guardrail has got lot of vulnerabilities, and we did not break any of it, but rather we show uh, what is its key vulnerability and how you can exploit it. Yeah, that's all from my side. If you have any question, you can ask.
Thank you so much, sir. I think there's diversified research that you have been presenting today, right from ML to cryptography to a lot of other things. Thank you so much. Uh, Shravan, sir, do you wish to add? Shravan, sir, are you there? Uferiya ma'am, are you there?
Yes, sir. I'm here.
Shravan, sir, please go ahead.
Thank you, sir. Thanks for accepting our invitation and enlightening the faculty members from from different states throughout the country. Yeah, it is my great pleasure to express our sincere and heartfelt thanks to Dr. Subid Ali for delivering an insightful and enriching FDP session on cloud security, information management, and data security, and the cloud security models. Sir's comprehensive explanation of cloud security challenges, data protection strategies, and security models provided valuable knowledge to all the faculty participants. The session was highly informative, thought-provoking, and practical-oriented, encouraging deeper understanding and professional growth in the area of cloud and data security. We truly appreciate your dedication, time, and valuable contribution to the success of this FDP program. Once again, we thank Dr. Subid Ali for sharing his expertise and making this session meaningful and impactful. Thank you, sir. Thanks for accepting and taking the session.
Yeah, it was my privilege to. Yeah.
Dear participants, thank you. Dear participants, do you have any questions to ask to Subed, sir? If there are no, then we will be proceeding towards Praveen sir's session, which is the next session.
Yeah. Thank you, guys. Yeah.
Thank you so much, Subed Ali, sir.
Thank you.
Right. Bye-bye.